Welcome to this explainer. Today, we've got a really highly practical mission, and that is automating Postman authentication. You know, if you spend your days testing APIs, you already know manual credentials are just a massive friction point. It's the worst. So today, we're going to set up your environment so those tokens literally renew themselves in the background. Let's optimize that workflow. We have absolutely all been there. You're totally in the zone, your dark-themed Postman app is open, you're chaining requests together like a pro, and suddenly, bam, your flow is completely broken by a 401 unauthorized error. And why? Well, because that bearer token you pasted in just 15 minutes ago decided to expire. And it's usually right when you're about to hit that one critical test. So now you've got to stop what you're doing, navigate all the way back to your authentication endpoint, generate a new token, highlight that giant string of gibberish, copy it, go back to your actual test request, paste it in, and finally hit send again. It is such a visceral pain, and if you're doing this, say, multiple times an hour, it is just a massive drain on your productivity. Okay, let's really dive into this. A lot of folks get stuck in this terrible manual flow, right? Fetch, copy, paste, test, expire, repeat. It's an endless loop of wasted time. But the ideal state? That's the automated flow. You just click send on your API test, and Postman handles the whole shebang behind the scenes. It checks if you need a token, fetches it, securely injects it right into your request, and returns your data. It's honestly this beautiful, Zen-like state of API testing, and it completely removes human error from the authentication equation. So, to move from that painful manual flow to our automated ideal, we'll look at Section 1, Meet Pre-Request Scripts, the ultimate problem solver. A pre-request script is essentially exactly what it sounds like. It's custom JavaScript code that runs inside the Postman sandbox, which, by the way, is a high-performance execution environment based on Node.js. But the defining characteristic here, the really important part, is the timing. This code executes precisely before your primary API request is sent to the server. Think of it like a really powerful interceptor. It lets you run background tasks like fetching fresh credentials or maybe calculating a dynamic timestamp before your actual test request ever even leaves your machine. Now, what's really interesting about this slide is the strict temporal hierarchy Postman forces. When you hit send, it doesn't just look at the request. First, it looks at the collection. If there's a script there, it runs it. Then it moves down to the folder level, runs that script, and finally executes any script attached to the specific request itself, right before sending the HTTP request over the network. Placing our authentication script at the collection level is an absolute game changer. It means we write the code once, and it automatically guarantees fresh credentials for every single request inside that entire collection. It is the ultimate write once, run everywhere approach. All right, moving right along to Section 2, step by step, writing the auth script. The logical flow of our script really just breaks down into 3 core steps. First up, we need to define our background post request. This is where we format the URL, let's say an auth/token endpoint, along with our client ID and secret. Second, we have to actually send that background request. Actually, scratch that. We don't just send it, we send it invisibly in the background. We definitely don't want this to be our main API call. Postman gives us a very specific function for this. And third, once that background server responds with our shiny new token, we just extract it from the JSON payload and save it somewhere secure so our actual API calls can use it. So here is the exact syntax using Postman's built-in PM object, which is your main interface to the sandbox environment. To send the background request, we use pm.sendRequest, passing in our configuration object and a callback function to handle the response. Once we get that response back, res.json parses it so we can actually read the data. But the real magic? That happens with pm.environment.set. This is exactly how we securely inject the token into our environment state, saving it as a variable named access_token. By saving it to the environment rather than as a global variable, we make sure it's scoped perfectly to our current workspace context, meaning it won't leak into your other testing environments.
Okay, our script has successfully run, it fetched the token in the background, and it saved it. Now what? Let's go to Section 3, applying your access token.
And this brilliantly illustrates how all these pieces just snap together. You open the authorization tab at the very top of your collection, make sure it's not on an individual request. You set the auth type to bearer token. Then, right in the token field, you type double curly braces around your variable name, so double curly braces, access token. Those double curly braces are just Postman's standard syntax for variable injection. Finally, you just make sure every individual request inside that collection is set to inherit auth from parent. Boom, you've now created an incredibly seamless, robust abstraction layer. Your script handles getting and updating the token, and the collection automatically wraps it into the authorization header of every single call. You will literally never manually paste a token again. How great is that?
To really show you why this matters in the real world, let's look at Section 4, Real Support Scenario, Zero-Touch API Testing.
Imagine you're an IT support engineer, right? And you've been tasked with testing this highly secure, incredibly strict payment API. Their security policies dictate that access tokens expire every 10 minutes. If you're doing this manually, it is an absolute nightmare. You're constantly watching the clock, breaking your focus, and honestly refreshing your token more often than you're actually testing the data. For our demo scenario here, we can replicate this exact friction using the free Postman web app, setting up a local mock server right inside Postman to act as our fake hyper-expiring authentication endpoint. 30. That is the number of consecutive test calls our support engineer just executed against that super strict payment API over the course of several hours. No breaks, because they placed that PM send request logic in the collections pre-request script and used hashtag access token at the collection authorization level. Postman just quietly checked the environment variable, realized the token was expiring, fetched a new one from the mock server, and injected it into the header 30 times in a row. 0 401 errors, 0 manual token updates, just complete zero-touch API testing. So the crucial point is this. Automation isn't just about writing cool code. It's about reclaiming your time and your focus. Take a look at your own workflow right now. If you implemented this simple pre-request script today, if you never had to manually fetch, copy, or paste a bearer token again, how many minutes or even hours would you save this week alone? How much sheer frustration would you eliminate? The tools to banish those 401 errors are already sitting right there in your Postman client. Stop working for your software and start making your software work for you.